Welcome to today's class. Today's class is Indices Part 10. Indices Part 10. It is actually a continuation of Indices Part 9. Under indices, there are many questions under indices that I cannot treat it in just one class. That's why I'm breaking it down into different parts. So I would advise if you are coming across my video for the first time, do well to go through part 1, part 2 till part 9 before coming over to part 10 so that you understand it better because they are all linked up together, especially part 1. Part 1 is actually the introduction of this topic. So do well to go through the part 1 aspect before coming over to part 10. All right, so under indices part 10, we have two examples. The first one is if 5 raised to power 2x plus 1 plus 5 raised by 2x is equal to 150. Find the value of x. I am going to solve number 1 using two methods. So I'll call this one method 1. 5 raised to power 2x plus 1 plus 5 raised to power 2x is equal to 150. Okay, from our knowledge of indices, that's why I'm advising you should go through part 1 before coming over to part 10. There is a law of indices that we call multiplication law, or you call it addition law. The law states that if you multiply two numbers with the same base, for example, what we have here, x raised to power n times x raised to power n, you notice that the bases are the same. So when you multiply two numbers that have the same base, you add their powers. So this simply means x raised to the power of n plus n. So looking at this question, we can rewrite 5 raised by 2x plus 1 as 5 raised to power 2x times 5 raised to power 1. That's it. Because when the bases are the same and it is multiplication, we can add their powers. So looking at this, the base here is 5, the base is 5. So you can also express it this way by adding their powers. All right. Plus 5 raised to power 2x is equal to 150. Okay. Now if you look at it, this 5 raised to power 2x, this 5 raised to power 2x, I can factorize it out. So if I factorize 5 raised to power 2x, I'll be left with 5 raised to power 1 here, which is 5, plus 1 is equal to 150. Why is it so? If you remove this bracket, you have back this line. Because 5 raised to power 2x times 5, this is it, plus 5 raised to power 2x times 1, this is it. So which means that this line is the same thing as this. And so from here, we'll have 5 raised to power 2x times 6, because 5 plus 1 is 6, is equal to 150. Now, our aim is to find the value of x. Our aim is to find the value of x. So at this point, we can divide both sides by 6. If you divide both sides by 6, you have 5 raised by 2x times 6 divided by 6 is equal to 150 divided by 6. And so this 6 will cancel this 6. You'll be left with 5 raised to power 2x. 6 cancels itself. 1 goes into 15 2 times, remaining 3. Carried and added, it becomes 30. 6 goes into 35, so that's equal to 25. And so 25 is the same thing as 5 raised to power 2. So this is 5 raised to power 2x is equal to 5 raised to power 2. Now you notice that the base in the left hand side is 5, the base in the right hand side is 5. So it therefore means that, let me continue from here. It therefore means that the powers must be the same. So 2x is equal to 2. And for us to have x, we divide both sides by 2. So that this will give us 2x divided by 2 is equal to 2 divided by 2. And these two will cancel this. So x is equal to 1. X is equal to 1. 2 will cancel here, 1. So that is the value of x. And how do we confirm it? If you carry the value of x as 1, put it in this expression, it will give you the same thing as this. You can try it and see. If you carry the value of x, which is 1, put it in this place. This will be 5 raised to power 2 times 1, which is 2. 2 plus 1 is 2 plus 1 is 3. So that will give you 5 raised to power 3. And 5 raised to power 3 is 125. And so 2 times 1 is 2. 5 raised to power 2 is 25. So that means that that answer is correct. X is 1. Because when x is 1, you have the left hand side being equal to the right hand side. Alright, so quickly let us look at question number. Okay, question number 1, I said I'll use 2 methods. So quickly, let me show you another way of solving it. Okay, let's see another way we can handle that question. From here, so I call that method 2. Now from here I can say let 5 raised to power 2x equals y, which means wherever I see 5 raised to power 2x, I'm going to put y. So this place will now be y times 5 plus y, because instead of 5 raised to power 2x, I'll put y, is equal to 150. Y times 5 is 5y plus y is equal to 150. So 5y plus y will give us 6y, and that's equal to 150. So for us to get y at this point, we divide both sides by 6. If you divide both sides by 6, you have 6 will cancel here, 6 here, 1, 6 here, 25. So y is equal to 25. But take note, we made a statement. We said let 5 raised to power 2x equals y. So it therefore means that 5 raised to power 2x is equal to 25, because y is 25. And so from here, 5 raised to power 2x, 25 is the same thing as 5 raised to power 2. The base in the left hand side is equal to the base in the right hand side. So it therefore means that the power in the left hand side must also be equal to the power in the right hand side. And so if we divide both sides by 2, we'll have x is equal to 1. So that will give us the same answer as method 1. So quickly, let's look at question number 2. Question number 2. Question number 2 is saying if 3 raised to power 3x minus 8 minus 1 over 3 raised to power x minus 2 is equal to 0. We are to find the value of x. We are to find the value of x. Now, if I move these over to this side, I'll have 3 raised to power 3x minus 8 is equal to, if I move this over to this side, take note it is negative in the left hand side. When it crosses over to the right hand side, it will become positive 1 over 3 raised to power x minus 2. Still recall from our knowledge of indices, that's why I'm advising you to go through part 1 before coming over to part 10, because that's the beginning of this topic. There is a law of indices that says negative power law. If you have a number raised to a negative power, the answer is simply 1 over that number, the power becomes positive. So if you compare this right hand side and what you have there, you see that we can move it to this, meaning this will give us 3 raised to power 3x minus 8 is equal to 3 raised to power minus into x minus 2. I'm applying that law, negative power law. And so at this point, the base is 3, the base is 3, so it therefore means that the power here, which is 3x minus 8, must be equal to the power in the other side, x minus 2. So this gives us 3x minus 8 is equal to minus x plus 2. Collect like terms. You cannot add these two because they are not like terms. You cannot subtract these two because they are not like terms. So if we collect like terms, you have 3x plus x. That is when minus x crosses over to the other side to become positive. And then when 8 crosses over to this side to become positive. And so that will give us 3x plus x is 4x is equal to 8 plus 2 is 10. So for x to stand alone, we divide both sides by 4. 4 will cancel this 4. X will now be 2 goes here 2, 2 goes here 5. So we have 5 over 2. But we cannot leave the answer like that because that is an improper fraction. So it therefore means that x is equal to 2 whole number 1 over 2. Alright, so that's the answer to question number 2. And with that, we have come to the end of this video. Please do well to click on the subscription button if you are coming across my video for the first time. Bye for now.